let's use this extra method to say hi. Welcome to Spring.io from my side. Interesting that so many people show up. I was assuming that everyone is building microservices these days. So it's kind of like, is that what you're talking? Oh, well, that's not what I'm going to talk about today. What I want to talk about is basically what you can do to keep structure alive in your, let's say, more monolithic application. I want to start with contextualizing, okay, why I think this is something worthwhile pursuing, and we're going to get into a bit of the benefits and downsides of microservice applications. But then it's going to become pretty technical. I have a tiny boot extension I want to show you that will help you actually maintaining that structure and achieving quite a few other goals that people usually have when they go to microservices. So that might be something that you're not even, or you don't even have to move to microservices for to actually achieve those goals. But first things first, my name is Oliver Drotbohm. I've been mostly known for working on Spring Data project. There have been some reorganizations in team structure recently, but I'm still part of the team, still doing that, but focusing a bit more on all the other stuff that has always surrounded my work in Spring Data, just as the Modulus stuff, architectural framework stuff, what have you. I quickly want to summarize some of the traits that you get with these two different or opposing architectural styles. I'm not trying to cover everything or have a detailed comparison. I much rather want to focus on certain aspects that I think make this alternative approach quite appealing and interesting. So the fundamental idea is that we have four concepts that we have to sort of consider. One is the bounded context, which is kind of some logical structure within your application, some logical unit, the order management, the customer management, shipment, supplies, what have you. We have deployment units, the question of what kind of deployment units actually make up our overall system. We have internal invocations within those deployment units, and we have external invocations across deployment units, right? Because it's different processes. So with with monoliths, it's basically a bounded context within a single deployment unit, and all our cross-module invocations are internal ones. Whereas with microservices, we sort of tie the deployment unit to the bounded context. That's the fundamental idea, right? Which also means that these interactions now all of a sudden get cross-project invocations, right? With all their ups and downsides. So while it's probably less likely that you by accident just invoke some component via HTTP in the microservices world, it's pretty easy to do so in a monolithic arrangement where you have just a Spring Bean and you just put an add auto wired to some other class and some other module, and then you just wire this thing up and can call a method on it, right? And that's how these architectures, especially on the left side, degrade very quickly. And I really want to have a look at what we can actually do to keep this structure on the left side around. So the benefits I see on a more monolithic approach is that the idea, again, fundamentally deploying multiple bounded contexts in a single deployment unit. A benefit, especially when you start a new project, when you explore new ground, it's that the bounded context boundaries are much easier to refactor than if you started with a microservices project, where you just basically put APIs in place, and by the very first time you deploy these things, you have to now all of a sudden arrange breaking changes in general, what have you. So moving code around is much easier in a let's say a monolithic code base, right? It's very easy to test the system overall. We can just use Spring integration test functionality. We just bootstrap the thing, just call methods, invoke REST APIs, what have you, right? So that's pretty easy. As I said, the chance for degradation is given, and that it's actually in place is one of the reasons that so many people look into microservices. So just like that well-defined structure that we all started with, then over the course of time basically degrading, and that making the further development of the system much more complicated. And what's also not really easy, or like I haven't seen anyone really approaching this before, is how do you actually test individual modules? We can get into the question of like structuring your monolithic application. You can of course use like things like Maven modules or Gradle modules or what have you to structure your monolith internally, but just like bootstrapping, let's say, 2 or 3 of them together in combination without too much effort isn't like really a first-class citizen in the testing support in Spring Framework or Spring Boot Framework, or hasn't been so far actually. For microservices, the downsides I see, and that actually coming to the goals that I want to achieve with stuff I sort of have prepared here, is that the bounded context interaction is remote. That means instead of a local method call that can either succeed or throw an exception, we now have to serialize the payload. We have to invoke a network call, which is much more expensive, much more failure scenarios, right? The other system could not be available. The system could be available, but the network could not be available, what have you. So there's a lot of stuff you have to do that you actually have to guard against, and then add extra code to sort of mitigate those problems, right? Hystrix, all these kinds of things, which ironically sort of defers your actual focus from writing business code to, oh, I need to put this Hystrix stuff here and what have you. So you basically focused on integration on the infrastructure level here. Testing individual modules is fine, works pretty well. The reason I marked this with yellow is that when you have a lot of interaction between the components, that's not only an indicator that your kind of setup is, or your granularity is maybe something you should work on. You also run into the situation that you have to bootstrap other systems, stop or mock other systems to actually integration test those modules, which can be quite or can introduce quite a bit of effort as well. As I said, refactoring context boundaries, is quite a significant effort, because once APIs are published, especially if you have these individual services managed by different teams, then it's not only technical decisions, then it's political decisions. Can the other team actually change that API for you? How do you manage other clients that have relied on the previous APIs? Yada yada yada. You're talking like interaction on a completely different level, right? Rather than just like refactoring, using your refactoring capabilities of your IDE to just like change a method name or a property name or what have you. And what's also quite a challenge is that how do we actually test the system overall? How do we actually test like a business flow from end to end? We need to bootstrap all the systems. We have to have them around, and then we also need to trace the calls that probably happen between the systems, and that's quite a challenge. So especially the testing individual modules and aspect is something that people often start with that's the reason they start with microservices in the first place, because they want to achieve that, right? There's no way you can really nicely bootstrap a part of a Spring application. I mean, how would that work, right? So and that's something that I basically took a closer look at, and it turned actually into this particular project that I want to show you. And I have this applied to a sample code base that itself, or in turn, is developed in a project that I'm having with the local university in my hometown. They're basically letting students in 3rd semester software engineering build a web application with Spring Boot. What could possibly go wrong, right? They don't have half a semester of Java expertise, no database lectures before. It's really fun to watch and interesting. But we basically provide them with sort of a skeleton application that's centered around an e-commerce application framework, sort of. It has a set of business modules, so we have users abstracted, we have orders abstracted, we have a catalog, and an inventory, which basically catalog has products, right? So general descriptions, prices. Inventory has products plus a certain amount, so we basically it's stock keeping, and the orders refer to products in the catalog, so they have line items that you can basically put into the order, and whenever you complete an order, there's API for the inventory to update the stock, right? So if I'm ordering like 5 TVs, the stock has to be reduced by 5 items for that particular product. We also have the concept of business time. It actually, what's going on, like from a business point of view, in this doesn't really matter for this presentation. There's just a couple of things that I wanted you to focus on. So I have the solid lines, or the solid arrows are component dependencies, which means in that module there is a spring bean that has a reference to a spring bean in the inventory module, right? Or the orders module has a spring component that itself has a dependency on business time. I'm going to get to that back in a second, because that's really important. That's really something to have a look at and to keep an eye on when you're actually evolving those systems. The other dependencies are plain type dependencies, right? So we have, let's say, the inventory has an inventory item, which is effectively a product plus some amount, right? So that's JPA. In this case, it's JPA entities, and that's just a plain type dependency. It's not like a Spring component dependency. Why that's important, I'm going to get back in a second. And you already see, like, people that like maybe more senior or having like their architect glasses on, they already see that there's a problem in this code base, right? Okay, so we're going to see code in a bit. I just want to start with the thing that I'm going to show you. It's called Modulus. Like the term, I know I didn't coin it. I haven't really found an ultimate source for it. I originally used it in another talk, I think a workshop I gave last year or 2 years ago here, which was called Refactoring to a System of Systems, where I basically suggested to like build a monolith in a certain way, and to prepare it for extraction into microservices. And this is, there was a lot of feedback that, okay, there's no real framework support for that kind of development, no active, I mean, there's nothing is in the way between the framework and you to actually build something like this as well, but out of the box, there wasn't something usable. So what's the idea? So the idea is that we sort of start with the question, okay, how do we map those logical modules, bounded contexts, what have you, onto our code base? Because when the rubber hits the road, I mean, these PowerPoint presentations are fine, but at some point we have to find a means to represent the customer or the orders module in the code base, right? And the fundamental assumption is that within your Spring application, you usually have the application class in the top level package, and then you have business packages right underneath that. So that's basically the thing here, right? So you'd go ahead and put your application class in the very top level modulith package, and then in my example case, we would have .orders, we would have .inventory, what have you, right? So just package by component is, if you to speak about it in Simon Brown's terms, he has a lot of has a decent talk about that. I had like 5 or 6 years ago, I've been traveling conferences with a talk that was called "Whoops, Where Did My Architecture Go?" If you Google for that, there's a blog post about that. Why I think that kind of top level structure at least is a decent start. Has a lot of consequences about visibility rules, because we can use the Java package scope here to hide components from the outside. It's kind of interesting. I'm going to come back to that in a second. But that's the fundamental idea, right? And then we can make use of that by just one tiny change, which is exchanging that add Spring Boot application with add modulith. And that's basically the sign to the library that you opt into this package structure. There are a lot of knobs and additional annotations where you can also use different kinds of package structures to make it work with that kind of system. But by default, you don't need to do anything but change that annotation. And actually, at system runtime, that of course in turn is annotated with add Spring Boot application. And at runtime, at production runtime, nothing is different. So it basically just says, okay, I'm opting into this package structure because we can then later on in the tests do certain stuff to that, or we can do stuff by analyzing that structure that you have there, right? So I'll show you that in a sec. So we have this kind of this package structure here. You should see that. I hope everyone in the back can sort of see that. You see a lot of business packages. There's more than what I had on the slides. There's like the accountancy. There's payment support, user accounts, what have you. It's the fundamental idea is that you have these packages, right? We also have sub packages. The web one down there, we can use that. But what we can now do, there now is API where you can basically go ahead and say, I think I should have that somewhere even. Where you start with something like that in a test. And that first line here, modules of sales.sample, that's the fundamental application class. And that goes ahead and basically analyzes the types within the packages and the Spring components for dependencies between the Spring components. And that implicitly creates a tree, or at least a graph, of dependencies between the modules, which we can then work with and use to actually help you analyze that and do certain things to it. And that's what I want to get into going forward here. Right. Because now that we know about the dependency graph between your modules, we can do the following. We can allow you to basically express, I want to bootstrap that module and that module only. Right? That's pretty easy, and it's something that's built on the Spring Boot support, testing support that has already been there for quite a while. We always had these kind of the support for layer annotations, right? So that's basically Spring Boot testing annotations. Data JPA test, data Mongo test, I think, is in there. That just would, like, from your Spring application in a boot in a test, only bootstrap the repositories. It would not bootstrap any services or components, what have you. No Spring MVC. Mostly for the reason to optimize for speed, right? So for bootstrap time. The same for web MVC tests. It would bootstrap Jackson and it would bootstrap Spring MVC, but all the controllers would have to be mocked out. So the question is, when we do this for layers, what would prevent us from doing that for vertical slices, for business slices, right? So on that level. And that's basically what, on top of that, on the module test annotation basically is. So you'd go ahead and in your integration test, let's go ahead. We have this integration test here. It's in the module package, so in one of the business packages, and it says add module test. And that basically goes ahead and on test bootstrap starts that analysis of the module structure, and then finds out, okay, all the components that are just in that package, and reconfigures the Spring Bootstrap to only see that package effectively, right? Component scanning, JPA entity scanning, all that kind of stuff. Right? So let's see that in action. For the catalog, because why do we start with the catalog? It's the easiest thing because it doesn't have any outgoing dependencies. So let's see how that works. That's not here we go. Sorry about that. Catalog integration test. So for now it's just a Spring Boot test. I can run it, and then I hope that's visible for everyone in the back. There's nothing special happening. It's just like 10 tests that have been executed. The entire application was bootstrapped, like all the unrelated stuff, everything that doesn't have anything to do with catalogs has also been bootstrapped and of course checked, which is a bit of a downside even, because if you now break some kind of dependencies like Spring Bean dependencies or something in an unrelated package, these tests will fail because of that, right? So it's not really isolated. So what we can do instead is we can switch to the add module test annotation. Never mind the verify automatically false here. I'm going to get back to that in a second. But I'm going to rerun the tests, and then you will see slightly different output. You will get told that, okay, we're starting a module test for sales point catalog. Geez, that screen resolution is a bit hard to work with. That's the module that's bootstrapped, so it has a logical name, it has a base package. We inspect all the Spring Beans that are in that very package and find out about references to other Spring Beans. And we haven't found any, that's why we say here. And we have a single Spring Bean in here, it's a public one. That's why we have a plus here, a public class. I could get back to that in a second. And we have a couple of shared modules. That's something I have set up. I don't want to go into. It's basically a mechanism to, from all the modules that we have available, to always bootstrap these as well, and not having to explicitly declare those. It's something you can tweak in the monolith annotation. But let's spare that for now for the sake of simplicity. So it basically then tells you which modules are bootstrapped, and you see the user account module is bootstrapped, the core module is bootstrapped, and the support one, and then it tells you, it reconfigures the auto configuration and entity scanning to those packages, and that just like works as before, with the upside that any kind of like errors or bootstrap errors that would have been called by other modules not actually breaking this test, right? That's pretty much it. All right. So far, so easy. Let's go ahead and have a look at the inventory. What you see here, and what's probably some of you might have realized already, is that we have a cyclic relationship between the orders package and the inventory. And that's actually an architectural violation, and we're going to get that reported if we try to bootstrap the inventory test. There we go. That's weird. That should fail. I hope it fails. No, it doesn't. Nice, I've probably checked out the wrong... one sec. Yes. I got lost in the... history. I need to check out the... Where's my cursor? There it is. I need to check out the right... Oh well, that works well. The right... Gosh, what is it? Sales point. Imperative state. We need to check out that one. So, I'm sorry for the... Are we here there? Check out commit. Check out. That should be it. Well, okay. That looks different now. Just a quick refresh, hoping that everything... I'm hoping that everything breaks as expected. It doesn't. Oh well, yeah. It's not supposed to. You see, we have this verify automatically set to false. That's because I had this architectural violation built in all the time, and to actually get this running in the first place, or not failing in the first place, I had to disable the verification. So if I now go ahead and switch that for that, which is basically enabling the verification, then fingers crossed this should now fail. Yeah. All right. So it basically reports that we have an architectural cycle between inventory and order. Where is this coming from? This comes from the fact that, we need to go back here, that our order implementation has, I basically had to break it, I had to break it to introduce this violation because, of course, if you, like, I prepared that stuff, so it should have been, it shouldn't actually have that violation in the first place, but to just show you what I wanted to shoot at, then I had to introduce it. So what this kind of thing does is, on completion of the order, we actively invoke the inventory to update the inventory. And you see that method signature here takes an order, and that inventory lives in the other package, which means there's now a cyclic relationship between inventory and order, right? Order needs to know about the inventory component. It needs to have that, while when I want to bootstrap the order, that order module, it needs to access that inventory bean. But at the same time, we have a type dependency on order within that method here. Right? So, right, it's just that declared thing here. So what we can do, and that's why I already checked out that other, Jesus, that arrow is sort of gone. Yeah, check out commit again. Check out and did that work? Ugh, jeez. Git reset hard. Git checkout spring IO. There we go. All right. Yeah, go away. So refreshing this. My gosh, why is this arrow gone? So I fixed that implementation or that issue by using something that Maciej was just showing in the talk before. So we have support to publish application events in Spring Data. We have had this support for quite a while already, which means that we can change the implementation to actually just look something like this. So instead of actively invoking the component in the other module, we just raise an event, and we do that by using the Spring Data abstract aggregate root capabilities to register an event of order completed, which then publishes an event to the Spring application event bus, which then in this case here invokes an event listener on the inventory order, this thing here basically. That event listener is triggered. Why is that important? And let me get back to the slide deck. So we basically replaced that component dependency to inventory with publishing an event and the inventory just listening for that event. That's important because we sort of broke the dependency cycle, and we don't need the inventory to actually be bootstrapped when we run the orders system, right? So or the orders module. Let's go back to the inventory tests, and this now should work without, and it actually worked. You've seen it before. Should now work and not report the violation anymore. The bottom line, there's a twofold bottom line here. The one is that you should critically review all the cross-module component injections, because the more you have of that, the more stuff you actually have to bootstrap if you want to bootstrap that single module. Like if you have let's say orders had this dependency to inventory, so when we want to bootstrap orders, we have to bootstrap inventory as well. So the less of these connections you have, the easier it is to test that thing in isolation. And the other thing is that this can usually be achieved by just publishing an event. It's not even like involving any kind of Kafka or a cross-process event publication. It's just using the eventing mechanism internally. And the third thing, actually, that's what I wanted to mention, is that you should have understood that if you actually introduce a cyclic dependency by accident, setting up your tests like this would actually basically reveal that, right? So it's not that they go unnoticed, which is usually the reason for the degradation of the structure in the system. So how much time do we have? 20 minutes. Okay. So the thing is that Modulith basically understands and differentiates between 3 types of dependencies as of today. I haven't really found an important third or fourth category. If you happen to play with it and think things should be improved, please provide feedback. I always appreciate it. So simple type dependencies is just like as I said, inventory item to product, for example, right? So simple type dependencies. There's component dependencies, so we analyze Spring Beans declared in in the modules for constructor parameters, yes, even for field injection, although that's of course also rejected when you put, turn on the verification, or which is enabled by default. And there is events and event listeners, because event listeners usually work exactly the other way around, right? If the inventory is listening for order events, there is no dependency, no module dependency between inventory and orders, but it's rather the other way around. We publish the event for the other one to listen to. The ones that you want to critically review are the component dependencies, because they actually make your testing life quite a bit complicated, and I'm going to show you why by actually trying to move the orders tests to the Modulus testing infrastructure. So we want to test this thing actually in isolation, and I'm going to show you how Modulus reports that there is some component that is not bootstrapped, but that's required for the test to run. So let's go to order tests. Right. So this is the order tests. As a start, it actually uses the Spring Boot tests. So you see they are working. We're using an abstract base class here. It says Spring Boot tests, yada yada yada. So it's again, as of now, bootstrapping the complete application. So what we want to change this to is to use the module test annotation. I can go into what the extra includes does for now. We can skip that. I can get to that in a second. So what I'm now expressing is I want to bootstrap the orders module, and by accident I want to bootstrap the catalog as well. But let's see what happens if we do that, and then I can get to you in a second. So it's breaking. We can sort of cancel that already because the the output should be telling enough on the first test case. So what you basically get is there's no qualifying bean of business time available. If you remember in the slide deck I had, there was a dependency on the business time module, and that's presented through that private final field business time that is then it basically is exposed via the constructor created via Lombok here. So we actually by that have set up a module dependency between the order and the time package. This is where business time lives, and there's a Spring component for that. Right? There's default business time. It's an add service. So that means we of course cannot bootstrap orders tests in isolation, because it needs that particular Spring bean, right? It needs that other module to run to satisfy the global dependency graph. So there's two things that you can do now. The first thing is, and that's actually built into Spring Boot out of the box, is you can just define a mock bean for that particular component, and you can run it, run the test, and then you should see that like stuff just works, right? And that's actually, I like that quite a lot, because what you do is you say, I want to start the orders module, because it's a module test, and to actually make that work, I have to mock this component and that component and this component. So you're pretty clearly describing like your module plus the external dependencies, right? And depending on what you want to do, you could of course like then go ahead and set up business time to actually like mock interactions or what have you. Another approach to this is, and an alternative is, that you could go ahead and say, well, I might not just want to bootstrap this particular module, but all direct dependencies of that module. Right? So this would now include, what's going on? Is it running? No, it's not. I just ran it. What's going on? What? Save. That's crowd computing. It works. Ah. So what you see here, let's have a look at the log output, because that's now becoming interesting, right? So we find out that the orders module has module dependencies on user account and time. So by this persistent order manager probably has something like the user account manager injected. There's an orders repository. You can see that there are all like package protected classes. That's that little O here. It was a plus before, if you remember. And we also extra include the catalog in the bootstrap phase. And then that actually means that these modules are actually bootstrapped, right? So you can get a pretty good overview what actually gets run. And that sort of helps you to just like, okay, now the business module, the actual business time component in this case would have been run in this case, right? So what you've seen by default is the standalone one. It's basically just like run this module only, and whatever kind of references out of the module you have, you need to mock them. That's the one way of doing it. You can use the direct dependencies bootstrap mode that would just like include one layer more, or one transitive dependency more. And there's also that all dependencies mode, which basically from the entire module graph just picks the node and just runs everything that's needed downstream, but not everything unrelated, right? So that would just work as well. It's pretty much the closest you can get to Spring Boot tests, but avoiding to bootstrap all the other modules that you don't need in this case. All right, so that's the test support. That's pretty helpful, I think, already. Probably needs a bit of getting used to like manage these module dependencies. It's something that at first, when you haven't like been used to that kind of stuff, it feels like, okay, I'm constantly getting the structure of my system in the face, basically, or basically held before me. But it's pretty neat to actually avoid introducing any kind of unwanted dependencies, right? What we also do in the verification step is that based on the module packages, we ensure that they are cycle-free. So that's actually why those bootstraps without that verify automatically equals false flag failed in the first place, right? And that actually gives you a lot of like confidence that you have a sort of well-structured module setup, because if there's no cycles in there, there's like a directed acyclic graph, and you sort of know that you will have leaf modules and you will have root modules that will just depend on others. So the chances are that if you have a cycle-free module arrangement, then that your system is pretty decently structured in the first place, without you defining explicit dependencies and what have you. All right. There's more to this. We can sort of hide components from other modules. You can define, let's say this is the API package, this is an implementation package. I wanted to skip that for now, just because of save a bit of time, and want to get to something that I find kind of interesting, which is the documentation aspect. Because usually you start with that set of boxes on a PowerPoint deck, and then you just put that into code by some means, and as soon as stuff sort of evolves, it's pretty hard to keep the documentation up to date. And like if, let's say, you introduce another dependency from one module to another, and the thing is, just as with we got all this kind of structural analysis without really doing much to the application except changing that one annotation, we can use that structural information that you provided, implicitly provided, to render out like diagrams that reflect the actual state of the system, right? And that kind of there's just a tiny API that you can use for to create those diagrams again in a test usually, and that looks something like this. I can pull that up a bit. So you again say, okay, go ahead, please analyze the module structure. Then you use that documenter module, and there's a couple of options that you can define what should go into the diagram, what shouldn't. And then there's just a tiny, just that very method here, basically saying, okay, just dump me all the modules as plant UML diagrams, or just take every module and create a diagram for every module. Where you say a diagram for every module, these ones down here actually include the module like under suspicion, basically, and just that the diagram then contains all the incoming dependencies to that particular module and all the outgoing dependencies. So it's basically put this in the focus and like what's the context, what context does that module live in? Whereas the former here is just basically the kitchen sink, everything and in its arrangements. As you see in that project, we just like write them out. You can of course define where this stuff is going to be written, what files, what the file name patterns are. But ultimately, this stuff ends up in plant UML modules, which I usually recommend to include into ASCII doctor documentation, and that would just like look something like this then, right? So it's kind of like that's the module diagram for the order component, and it differentiates again like the different dependency types. Saying the uses dependency type is basically a Spring component bean reference. Everything else depends on is just a type dependency. There's also the event in the overall diagram. It also shows the listens to dependency relationship that's up here, as you see. And that's basically what we sort of like refactored to when we basically undid the breakage that I introduced for the sake of showing that stuff. So that's the event listener. So just getting that kind of stuff from, let's say, from like your existing code arrangement for free, basically, is kind of neat, I think. All right. So what kind of context does Modulus now live in? Because it's not the first time that someone tried to put some structure in place, right, in these systems. One alternative that you could start with is multiple artifacts, which means I could go ahead and could have created a Maven module for all these individual business modules, right, and then have defined the dependencies in my Maven dependency descriptor, and then just have that or use that to basically control the dependencies. Because Maven already prevents cyclic dependencies between modules, so that's kind of neat, right? So that would have been an alternative approach. That's pretty fine. You can do that. You can still do that even with Modulith. We don't care in which artifact these things live. All that matters is what your class path looks like, right? The package structure on your class path, and we're sort of inspecting that. What's also nice is that I can actually test a module in isolation because I have everything there. The thing is that as soon as I need to pull in other modules that help me testing, as I pulled in the catalog module in the orders test because I wanted to set up some products to actually put into the order, and that's getting a bit complicated because the dependency arrangement in a module usually is a static one, right? So you declare that once, and then all of your tests sort of have to live with that arrangement. And that's actually or there's two more downsides. With that, with a module per business package, I would have ended up with, 12 Maven modules and 12 POM files that sort of all relate to each other. I've been in a project where even a simple module setup would end up with 36 something Maven modules. So that can be a bit overwhelming. So why not just keep them all together? Because we're going to deploy them all at once anyway, and just like try to maintain the structure in a different way. And what it also means is that like the internal structure, is now all of a sudden visible to anyone on the outside. So because of the jars probably getting published into some Maven repo, right? So someone else trying to use your piece of software would then just have to basically get together and select a couple of jars together. Another thing that you could try is the Java module system, which I think there's even a talk on that. I have to see that later today. That works pretty well as well. It has a couple of downsides that I find rather limiting especially for this kind of stuff. Java modules fundamentally assumes that you have an artifact per module. Right, so there's no way you can have multiple modules in an artifact, at least right now. I brought this up on the mailing list already. They're looking into it. It might just not be what they need, because remember, the Java module system was invented to actually be able to structure the JDK. Right, it's not at least. I mean, right now everyone thinks about it as the Java module system supposed to be used for your applications. That's not what it was built for, at least not originally, and I can see a couple of things like these are basically sort of getting in the way if you really want to take it into a real world application. Semantics of the opens keyword, yeah, that's a bit of reflection stuff, because you basically have a package or packages that you basically declare API, but there's no fine-grained control over what's exposed, so people start making separate packages and public types and whatnot. So if you wanted details on that, feel free to catch me later. And there's no support to dynamically assemble modules for tests, right? So that's kind of the stuff that I described before. There's external tools that you can use, things like JQ Assistant, Sonograph, JDepend, and I'd recommend you to do that, because especially I'm a bit familiar with JQ Assistant. It's a tool that basically pulls all your code base into a Neo4j graph database and allows you to query the database, and through the queries actually define rules. It's incredibly powerful. It's not, of course, only constrained to the source code, but can also inspect your Git commits and correlate these things. So there's a lot of power in these tools. However, they are usually more expensive to run, and they usually run during the build, right? And if I run stuff during the build, it's hard, or if I delay those checks to the build, there's no way I can use that structural information that I could maybe gain from within the test cases, right? So it's kind of, I want earlier feedback. Ideally, I would have see those structural violations even through the compiler. And there's a cool tool called Detective, I think, by Gunnar Morling. They built an APT processor that, based on a JSON file, sort of does similar things that we do. And it's not like imposing those package constraints, so you have to do a bit more. But at the same time, it basically causes the compiler or to get you the red underlines in your editor already. So that's something to look into. It's definitely, as I said, JQ Assistant, you can do way more things with it than what I basically try to do with Modulus. With distance to development workflow, I mean, when do you actually get the feedback, and what does this mean in terms of the ability to implement certain things, right? So the first thing is the compiler, the second distant thing is the test, and the third distant thing is the build system, right? So to reiterate, convention to map context to packages, that allows us to reason about the modular structure of your system. We can then build support on top of that to actually bootstrap parts of your system. There's even more to that in terms of more complex package arrangements, right? Arrange packages that have internal packages and access rules about that, and you can actually go ahead and derive documentation from that structure that you sort of implicitly created. There's the project website on GitHub. There are 2 talks I'd recommend that sort of discuss similar ideas. Modular monolith is Simon Brown, probably, I mean, I don't have to talk about too much about him. Discussing that package by component idea mostly in that talk. Majestic modular monoliths, I have to add that, is from sheesh. Excuse me? No. The guy behind this database stuff tool, Flyway, who's behind Flyway? I'm sorry about that. Click on the link and then you'll find out. Refactoring to a system of systems. There's a couple of recordings. That's a talk of mine, and basically touching the idea that I've just shown you implemented in a couple of places. That's it. I'll be around until tomorrow afternoon. Thanks for your attention. If you have any questions, happy to answer them later today. Thank you.